Select the major product of the following Diels-Alder reaction. And so, as with all Diels-Alder reactions, when we're predicting the product, we should first draw our general Diels-Alder framework, which shows us that we always have this diene system and a dienophile reacting to give us this 6-membered cyclohexene ring. And so what we want to do in solving this problem is to locate the diene, number it carbons 1 through 4, locate the dienophile, and label carbons 5 and 6. And so we can see here is our diene, and this is symmetrical, so it doesn't matter which direction we number. And as long as one component is symmetrical, it also doesn't matter which one of these we call carbons 5 and 6, because you would end up drawing the same product. So I'm just going to say 5 and 6, even though I could just as easily have reversed those and it would not change the outcome. All right, so now that we've numbered those, we should draw the framework for the product. So it's always going to be a cyclohexene. And where that alkene is, if we're following the same consistent numbering pattern, is always going to be carbons 2 and 3. So then we can continue numbering around the ring. And then what we want to do in drawing the product is to look at what was attached to the 2 starting materials and then make sure that we've still got that in the product. So on our diene, what we have is this 2 carbon atom bridge between carbons 1 and 4. So it's a little tricky to draw, but I'm going to try to put it in. So there's 1 carbon atom bound to another carbon atom that is bound to carbon 4. So this is going to make the ring pucker. So I'm showing this kind of sticking up a bit. And then what I see on carbon 6 is a cyano group. And this is a pi donating substituent. And so I expect that that's going to end up primarily in the exo position. So I am going to put that on a dashed bond. And so having the bridge pointing in one direction and that pi donating substituent pointing in the other direction, that is the endo product. And so if we're looking at our options, only one of them has this 2 carbon atom bridge. This is drawn in the proper 3-dimensional structure, but we should be able to number and see that it's the same. You notice this carbon here is flipped in terms of what we labeled 5 and 6. As I mentioned earlier, that doesn't matter. So I'm just going to say that's 6, 5. So then we'd have 4, 3, 2, 1. This is the same molecule, just spun around. So to represent the endo product, right, that means the bridge and the substituent are pointing in opposite directions. Here we've got the bridge pointing up and the cyano group pointing down. So that is actually the endo product.